just the reciprocal of differentiation. It's just the reciprocal of differentiation. It is the integration that is used to find the area of most of the curve or most of the shape that have irregular shape. As we said under the differentiation, that if you are given a function, you have to find its derivative, you find its divided x, right? And under integration, that function will be given to you, and you have to find that derivative, will be given to you, then you find the function back. That is why we say the reciprocal of integration. That is why we have some certain integral here, and you now look at these integrals, you see that most of them, all of them are in form of x. That means it is the derivative that are given back to find the function. So now, if you have, this is the symbol of the integration. This is the integral symbol. Now, if you have x raised to the power of n, x raised to the power of n, the integration of this is simply x raised to the power of n plus 1 over n plus 1. X raised to the power of what? N plus 1 over n plus 1. N is the power. Whatever you have as the power, then plus 1, then divided by that value, n plus 1. Plus a constant. Why do you always add a constant? Because under integration we have two. We have definite integral and we have indefinite integral. So these ones are under the indefinite integral. The indefinite integral will always have a constant t. Because in differentiation we talk of the differentiation of any function is what? Under the differentiation, we said differentiation of any function is what? So that's the reason why you have to add it back if you are integrating. I hope you understand. Because if you are integrating back, differentiation is back is going to be what? So whatever you have together, you have to add it back. So let's take this formula of this. Formula to this. X raised to the power of n dx equals x raised to the power of n plus 1 over n plus 1. So ax raised to the power of n, let us not have any coefficient here. So it's the same thing. So ax raised to the power of n plus 1 over n plus 1. So if you have a function, just like the function of a function that is given. So this is going to be ax plus b raised to the power of the power still remains n plus 1 over not the differentiation of the function itself. If I have ax plus b, what is going to be the differentiation of ax? Differentiation is what? A. Differentiation of b is a constant. It's going to be a 0. That's why we say a into ax plus. So integration of 1 over x is equal to the x. Don't forget under differentiation, we said differentiation of the x is what? 1 over x. So it's a reciprocal. Integration of exponential x still remains exponential x. Then integration of cos x is equal to sin x, while that of sin x is equal to minus cos x plus the constant t. So now, let's find it. Evaluate each integral. A. If you want to find the integral of x raised to the power of 2 dx, going by the formula here, what is our n here? Our n is what? So simply what are you going to have? X raised to the power of n, 2 plus 1, over what? 2 plus 1 plus a constant t. That's it. What is our final answer? X raised to the power of 3 over 3 plus a constant. That's it. No problem? So let's take the other one. The other one now is integral of 1 dx. Who can tell us the answer of this? Integral of 1 dx is just going to give us what? X. So integration of any constant. If I now ask you to integrate 3 dx, what is going to be the answer now? 3 dx. 3x, right? Just add the value. That's it. So now see, you have to find the integral of this. Integral of 6x raised to the power of 5 minus 2x raised to the power of 3 plus x. All the x. Just integrate it term by term. Term by term. What is the integral of this one? It's going to be what? 6x raised to the power of, shall we go direct? 5 plus 1 is over, that's it? Minus 2x raised to the power of, this is 3, right? So 3 plus 1 is what? Over, plus, are we together? So what of x? If you want to integrate x plus x raised to the power of what? 1. You have 1 here, right? X raised to the power of 1 plus 1 over plus a constant 4. this can go with this, right? So you have x raised to the power of 2. 2 here, 1, 2 here, 1, 2. Minus x raised to the power of 4 over 2 plus x raised to the power of 2 over 2. I hope it's clear. Any problem? So this, if you have to integrate this, so now look at this one. If you want to integrate this, the first thing you are expected to do is to write this part in this. Right? According to law of indices, if I have 1 over this can be derived as well. X raised to the power of n minus 2. Do you agree with me? X raised to the power of minus 2. So how am I going to write this one? Minus 3x raised to the power of what? Minus 2. How is it? According to law of indices, plus what? 9. All now let's find the integral of this. Integrate it term by term as usual. What is the integral of this one now? X raised to the power of minus 2 plus 1. Can we write it direct? Minus 2 plus 1 is going to give us what? Minus 1 over 1. Are we there? Minus 3x raised to the power of minus 6 plus 1 is what? Minus 5 over 1. Right? Plus, are we together? Plus integration of 9 is going to give us what? 9 plus 2. So finally, this is going to be written as what? This is minus x over minus 1 is going to give us what? Minus x raised to the power of minus 1. Minus here is plus. Because this minus will affect this. Are we together? So it's going to give us plus 3x raised to the power of minus 5 over 5. Then plus 9x plus the constant. I want you to understand it. So the last one there. The last one there, which is our E, we said we define the integral of I think this is our question, 4 times x minus plus x minus 1. Is it like this? So now what are you going to do? Just find the integral term by term. This is a constant. So this is what? What is the integration of sin x? What do you say is the integration of sin x? Minus plus x. Is it true? Minus plus x. So integration of sin x is minus plus x. Are we together? Minus, what is the integration of plus x? We said it was sin x. So it is equal to sin x. Minus, what is going to be the integration of 1 with respect to x? Integration of 1 dx is going to be what? X only. We just as this one. Integration of 1 dx. So we said it was x. So integration of 1 is x. So finally, what is our answer? Plus a constant. So we have minus 4 cos x minus sin x minus x plus a constant. That is how we find the integration of 1. There you go. Now, we have looked at the indefinite integral. Now let's look at some example under definite integral. Under the definite integral is just an integration with respect to limits. It has a limit. That is why we call it definite integral. If you look at this one now, a to b, integral of a to b. This is the lower limit, this is the upper limit. So f of x dx. After you find the integration, you now substitute the limits as f of b minus f of a. That is f of upper limit minus f of lower limit. After you finish your integration, you now put your limit. Example now. We have a. You are asked to find integral of 1 to 3, then 2x plus 1 dx. So let's find the integration of this. You just integrate this one term by term. Yeah, what is the integration of this one? 2x is going to give us what? 2x raised to the power of 2, right? Because our integration, we have 1 here, go? Silent. 1 plus 1, 2. 2 over, is it like this? Plus, what is the integration of 1? With respect to the x. It's x only. Are we together? So finally, our integration, 2 go with 2. So what do you have now? It's equal to x squared plus x. What is our limit? 1 to 3. Which one is upper, which one is lower? Lower is 1, upper is 3. And we are going to start with the upper. We substitute upper first, so it's going to be what? Anywhere you see x, you have put 3. 3 square plus 3. Do you see what I did?
minus lower, because we said f of b minus f of a, minus lower, let's put the lower limit. It's going to be what? 1 square plus what? 1. So this is now going to be finally is equal to 3 square is what? 9. 9 plus 3 is 12. Minus 1 square is 1. 1 plus 1 is 2. So what do you have? 10 units. That's all. 10. After you integrate, you just substitute the limit. Should we add another one here? Let's find the derivative or integral of this one now. B is integral of 0 to 3. We have minus 2x plus 6, then dx. What is the integration of this class? This term is going to give you what? Minus 2x raised to the power of 2 over 2. Is it true? Because we have 1 here. 1 plus 1 is 2. Plus integration of 6 with respect to the x is what? 6x. Are we together? So now this 2 can go with this 2. What do you have left? You have with minus x squared plus 6x. Are we there? So we have to substitute the limit of what? 0 to 3. Are we together? So what are you going to have now? You have minus, what is the value of x? When you substitute the limit, you have 3 square, are we together? Plus 6 into 3, all this minus lower limit. What is our lower limit, class? 0. So when you put 0 here, what will happen? 0 square is 0. Plus 6 times 0 is still what? 0. Are we together? So now what do you have? 3 square? 9. Then you have minus 9 plus 6 times 3 is what? 18. 0. Everything here is 0. So what do you have? Minus 9 plus 18 is equal to what? 9 units. So that is how we find we evaluate the definite integral. So far now under the integration, the scheme of work says we should look at the basic concept of integration. So we have looked at the basic concept of the integration, both indefinite and the definite integral. So these are some examples that we have took under that. And there are some aspects and there are some parts of the integration that we are not able to touch. We have integration by substitution, we have integration by partial fraction, we have application of integrations. That is when we use Simpson rules and others, trapezoidal rules and others. So now we don't touch those aspects now. We only touch those aspects in the further mass. But in general mass, this is the basic aspect that the scheme of work said we should touch. So I hope with this, you will at least go through some questions. You will not rely only these few examples that we have. You have to go through the textbooks, consult different problems, and make sure you are able to attempt all of them. I wish you all the best. The note was compiled by Mr. Sharif Abdulaziz. Thank you very much.